Hey everyone, welcome to our session on design patterns for centralized authorization. My name is Alice Gibbons. I am head of customer engineering at Diagrid. We are the folks behind the open source Dapr project. If you don't know about Dapr, that's okay. I will hopefully tell you about it today. And yeah, really excited to be here. We're going to talk a little bit about resiliency in computing, as well as Dapr workflow, which is one of the most popular APIs that we are seeing users use today. Jose?
I'm José Padilla. I'm a core maintainer for OpenFGA, and I'm a staff software engineer at Auth0, where we work with our fine-grained authorization product.
Awesome.
So, imagine a user making an order online, but they also need to update their address. The system needs to update both the user database and the shipment service. If either fails, the shipment will not go where the user is expecting it to go. Distributed systems aim to remove bottlenecks or central points of failure from a system. While they provide significant benefits, they also present challenges. L. Peter Deutsch describes some false assumptions that people new to distributed systems invariably make. I'm going to zoom in to 3 of them. First one, the network is reliable. In reality, we know that network calls to your second service, be it an API, an auth service, another database, can and will likely fail. This is the root of the inconsistency problem. 2, latency is 0. Reality is that network calls do take time. Making a user wait for 2, 3, 4, a number of different requests, whether it's to a database or another service, just creates high latency. And now we're forcing us into asynchronous eventual consistency patterns. And number 3, or 7 from this list, transport cost is 0. In reality, every network call costs CPU, time, data transfer. These costs add up, forcing us to find other efficient patterns. The dual write problem exists because these common assumptions are false. Now, can I get a raise of hands? Who has heard about this dual write problem thing? Cool.
And this is the application developer track, just confirming. So we have at least a few developers in here. 1 or 2? Okay, I'm getting some nods. All right, we have one. We have one developer in the back.
The dual write problem occurs when 2 external systems must be updated in an atomic fashion. A classic example is updating an applications database while pushing an event into a messaging system like Kafka. If the database update succeeds, but the write to Kafka fails, then our system ends up in some inconsistent state. There's a couple of other examples, like if you're writing to a database and then updating a cache. In the context of e-commerce, if inventory and payment consistency. In the context of a SaaS, you have account creation and email verification. And in the context of authorization, though, even if your application is a monolith and you're using a centralized authorization system like OpenFGA, you could also run into a similar problem. Let's say you completely delegate authorization decisions to OpenFGA, but also keep a copy or reference of that data in your local application. Writing data in one place and not the other might fail, and then one of the systems will be in an inconsistent state. OpenFGA is a centralized authorization system for developers. It's based on a concept called relationship-based access control, which is just an evolution of RBAC or ABAC. It is inspired by a research paper published by Google, where they describe how they built their internal authorization system called Zanzibar, which they use across their whole products. We package the best ideas of Zanzibar in a developer-friendly, open source project that is simple enough that anyone can use. And as a new achievement, we recently reached our incubating state in CNCF. Oh. Sorry. Imagine you have a system where you want to add a user as a member of an organization. and you store this membership information in your application database. You also need to tell OpenFGA that this user has a member relationship with the organization by writing a new relationship tuple. First is an authorization model. When you declare all the entities or object types that are relevant when making authorization decisions. This is a very simple example of a multi-tenant, role-based control system where different users can have different roles in different organizations. An initial implementation might look like this, but something could definitely go wrong during this two-step process. For instance, your application database might update successfully, but a network issue could cause the write request to OpenFGA to fail. Then later on, if any one part of your application checks if that user can delete resource permission, which our model does grant, OpenFGA will return false or access denied, even though your application's internal data says that they should have access. So how can we keep both the application database and OpenFGA in a consistent state? There are multiple strategies for mitigating the dual write problem. Sequential dual write, kind of like that pseudocode example that I just showed, is definitely the simplest approach. You write to the primary system, and then write to the secondary system. You hope for the best. You add some complex error handling to roll back the first write if the second fails. We also have transactional outbox. It's a pattern that leverages database transactions to update a primary system state and an outbox table. Events in this outbox table could be sent to an external messaging platform, such as Kafka. Event sourcing is a little like transactional outbox, except it eliminates the storage of the state, and instead writes to an append-only event log or event stream, at which point consumers can then process those events. And lastly, but not least, durable execution engine, which Alice will talk more about next.
Woo! Durable execution. Let's do it. Thanks, Jose. Amazing. So I wanted to talk a little bit about what durable execution engine is and kind of like simplify this into terms that I think are kind of easier to understand. I feel like the word durable execution is used a lot. And I think it makes a lot of sense that it's used. It's kind of a fun button right now. But really, like, what is the problem we're trying to solve here? Right? We know distributed systems will fail. We have talked about this, the fallacies of distributed systems, things like that, whether it's network unreliability, request latency, service unavailability, et cetera, et cetera, et cetera. Like normally that function state is entirely stored, within the stack. So once that application kind of goes down, you have lost whatever kind of local state you are running within your system, unless you make it stateful. So how do we limit these failures? And this kind of code, making this code execution persistent by using like an append-only log and using checkpointing is a really powerful way to do this. So essentially, the definition that we're using here is that durable execution is just make function calls durable. So make the state that you are saving within your, each of your application function calls, make that saved to where you are within your process at a certain time. And we want to recover from failures to your applications, near automatically. We want that to happen almost right away, and we want to limit the impact of that failure on your system. So for example, if that code is stopped halfway through, we want to be able to pick up from where you left off and then continue running, from exactly where it was going without missing a beat. This is implemented using a workflow engine. Workflow engines are super popular these days, and this is kind of what we are going to showcase being wrapped around this dual write problem to solve this issue. So this is where Dapr comes in. So how many people have heard Dapr? Show of hands. Yes. Okay, I love this. Dapr stands for the Distributed Application Runtime. We are a graduated CNCF project, been around for many years now. And essentially, Dapr is a set of APIs for building microservices. At its core, as developers, you want to build a set of services using a set of design patterns. Dapr enables you to do just that using, about over 10 APIs that we have now. Now, I'm going to specifically talk about the workflow API today, but I highly, highly, highly recommend that you take a peek at of the other APIs that we offer. For example, we have an Actors API that's very powerful for building systems. We have a message publish and subscribe API, service invocation. The list goes on. But essentially, Dapr is providing this workflow engine within the runtime, typically often run as a sidecar pattern. And then it also gives you a number of cross-cutting concerns, such as observability, resiliency, and security kind of built in on top. So zooming in on that workflow API, this is exactly what I was talking about with that durable execution engine, right? So this enables durable execution of potentially long-running business processes. We actually enabled, most recently, to run your processes like essentially forever. So if you have a process that might run forever, we can still do durable execution on that, which I think is pretty cool. So this enables patterns like chaining, task chaining, which we'll talk about in a bit, fan in, fan out, so executing some of your applications sequentially, waiting for external events, child workflows, and many more. We have seen this being used across a ton of industry verticals and use cases, things like AI agents and making those agentic workflows durable. So you can tell if every time I say the word durable, you can just like nod your head. It's like a fun drinking game. Just kidding. And there also is customizable retry policies per activity. We have a workflow unique identity, which is underpinned by the open source project Spiffy, and a number of other features like workflow versioning, which we are releasing very soon. So how does this work? From just like digging into the internals just for 1 second, I wanted to just like take a pause and look at how that checkpointing mechanism actually works in practice. Let's say I have a pretty simple like sequential workflow with 3 activities, and I have an input and an output. Each of those activities is deterministic, meaning that like whatever I put in, that input needs to be, for that input, the output needs to be the same for that same input, right? We are going to be using the workflow state store, and this is a bring your own state store from the Dapr perspective. So that means I can bring whatever state store I feel most comfortable with as an infrastructure engineer, whether that's like a Postgres or a MySQL, something like that. And this is going to be used for this append-only log. OK, so what's happening here? You can see this little GIF kind of running by. Essentially, every single time this workflow runs, we're going to start from the beginning, and we are going to save both the input to that workflow as well as the unique workflow instance ID. So then we're operating within the confines of that unique instance ID in that workflow itself. And then within each activity, I'm going to be saving the input as well as and then my business logic is going to run. So essentially, like the control switches from your application to the Dapr workflow engine and runs, Dapr workflow engine is going to, save your activity 1 input, activity 1 output after that activity 1 is completed. Then it's going to replay from the beginning and be like, OK, cool, I have my activity 1 input and output, meaning that means I can pick up right from where I left off, which is in activity 2. And again, each activity you can think of as your business logic that you're running from within your application. So this kind of allows this durability here. And again, we'll give like super resilient applications based on if they fail, they'll be able to pick up right from where they left off. So what we're going to talk about specifically is this grant organization membership workflow. And this is a super common pattern within authorization. I want to add a new user to my org. I think every single person here has been either added to an organization at some point or has added another user. This is using 2 databases. Again, like there's oftentimes when you want to have a local application database saving a subset of your auth data and then mirroring some of that within the OpenFGA kind of fine-grained auth database. So this is what it would look like kind of normally. I'm going to check those user permissions on an org. I'm going to create that team member in my local database, and then I'm going to add that team member to my organization within OpenFGA. So maybe you can see where this is going, but like imagine if this process fails at some point, right? We are going to get an inconsistent database. So this is what this would look like from a workflow perspective. It's mostly the same, but I'm just like calling out the specifics in terms of, we're of course going to check the permission of the user that's making that request. We're going to check that on OpenFGA. Only if that is successful, we're going to continue on, right? So each sequential action within workflows is predicated on the fact that like the previous ones run successfully. So I'm going to check that user permission. I'm going to then generate that user locally, and I'm going to assign those user permissions. within OpenFGA. And this is going to only ever complete sequentially or atomically for all of these things, or actually roll back all of the logic in order to make sure we have a consistent state across your authorization. Cool. So who's ready to see a demo? Woo! People are still awake. I'm like, guys, this is the last day. You're so close, OK, so I'm going to switch over to my cursor here. Is this big enough, or should I make the screen a little bit bigger in the back? OK, cool. So what we have here is we have a Dapr workflow application. And this is using Python. It is using the Dapr workflow SDK. And we are also using the OpenFGA Python SDK. So we have kind of best of both worlds here. You can see at the very top, I have my workflow definition. Again, this is all code first. We are writing our workflows using just regular bold Python code. And each workflow and activity is just its own function. So if you're familiar with Python, this should look like kind of familiar to you. This is called the grant organization membership workflow. I'm going to get an input, and I'm going to take extend from this Dapr workflow context. The main thing I'm going to do here is call each of these activity functions. And again, these are like my business logic that I want to do as a developer. Like all of the logic I want to put in my code needs to be running within those activity functions. This first one is that checking permission on org. So again, I'm going to check that permission for whoever is requesting this to see if they even can add someone to this organization or not. So this one, very specifically, going to head down to this one. All this is doing is this is where this OpenFGA SDK comes in. This is going to check this user permission on the org, and it's going to return either like a yes or a no. It's going to say, hey, can this person add another person to the org? Yes, no. Pretty basic. I'm not going to go through all the activities, but then the other thing I just wanted to call out here is that we have a manual override. So this is a feature of Dapr workflows where essentially I can come in and wait for an external event. So maybe this person does not have the correct permissions in order to add a person to their organization. That can be manually overridden in this time, which is like that's something that we wanted for our business in this case. We also have the concept of durable timers in here, meaning that like if I had kind of more of a monitor pattern where I wanted to check back on something after a period of time, I could also just again do this in code. These are these functions and these objects that Dapr SDK is providing you in order to kind of mimic your business processes as code. The other thing I'm doing here is I'm setting these custom statuses. These are really important from like a debugging and a troubleshooting perspective, because I want to know like at what point did my workflow like actually run to, what point did it fail, where are we at in each of our running applications, and that's what custom statuses are going to do. The other two activities, this is a sequential, so this is like kind of what's calling a task chaining workflow. So the next one is actually going to create that team member locally. We're using just like a local SQLite database here, so it's like just to simulate like a local AppDB. And then we're using Postgres in order to kind of simulate the OpenFGA kind of fine-grained auth database. And then last but not least, we are adding that user to that organization. That is that OpenFGA call to actually add those, those relation tuples into the fine-grained auth DB. And then we have the last thing I wanted to call out is this error handler one. And this is really important because we've talked a lot about this dual write problem. And if this fails halfway through, I want to make sure that my database stays consistent for both my local and my OpenFGA DB. And this is actually going to roll back any of the calls that have been made to ensure that this whole process happens atomically if there's any errors. Cool. So based on that, let's actually just run this. OK, so I'm going to kick off. I'm going to do a couple things. I'm going to see if it is running. No, it's not. So I'm going to run my Dapr sidecar application. And this is a kind of a one-to-one. You want to run your Dapr process. That's going to expose that workflow engine, and it's going to expose that workflow API to my application. And I'm going to use a Redis state store here. And that's just for my append-only log. Right? This is going to be the checkpointing thing that I was talking about earlier. So this is actually just calling out to a local Redis container that I have running on my machine. It's automatically kind of set up by Dapr for me in this case. And just to show you kind of what else is running, I also have, here's my Dapr stuff that I need. I also have this OpenFGA server running, and this is just using Postgres to store its fine-grained auth relations, kind of the stuff that Jose was showing earlier. Cool, so that's up and running, amazing. Then I'm gonna kick off my apps. Again, this is literally just a Python application. So I'm gonna run Python workflows py. We're gonna see kind of some stuff come through here. Essentially, this is gonna kick off a new workflow, or this is not gonna kick off a new workflow, sorry. This is gonna run the workflow application. It's gonna register all of these activities with the actual workflow runtime itself, so that the Dapr workflow engine knows, hey, this is a workflow, these are activities. And then I'm going to just check my database here and show you guys what is in it. So let's just take a look. So I'm going to send a request. You can see on the right here, I have 2 users, Alice and Bob, very classic users, and we have 2 of them. They are both stored in this is in my Postgres DB. And then I also have this SQLite. I have Alice, obviously the admin of this organization, and then Bob, who is a member. So in this case, admins can add other users and members cannot, right? Awesome. So let's just run this through and see this succeed, hopefully. I'm going to hit off this, Dapr. This is one of the workflows. This is going to start a new workflow instance. And you can kind of see this humming along down here. So essentially what this is going to do, this command on line 7 there, it's going to kick off a new instance of the grant organization membership workflow. It's going to pass it a user that is requesting this, Alice. She's an admin. It's going to add the user Charlie to both databases, and it should theoretically complete successfully because Alice has those permissions. So you can see on the right, I hit that get status kind of right away to see that it was still running. And hey, we have this team member, Charlie, was in fact created successfully. Let's see, okay, now it's completed, amazing. And then if I theoretically update my SQLite here, yeah, we got Charlie. We got Charlie in our org, we love that. And then I'm also gonna hit this, Postgres. We also see Alice, Bob, Charlie. Okay. Cool, so everything works. We know the app works. It's not smoke and mirrors, I promise. Now let's see a case in which, the person does not necessarily have the permissions here. So as I said, we have Bob. He's just a lowly member of the org. He cannot do much. We're gonna run this guy. We're gonna see Bob trying to add our friend Doug, and we're gonna see how this works out. So again, Alice, Bob, Charlie in the user base here, and we can kind of see, hey, there's theoretically a manual approver override. We are waiting for this case to run, and then we also are getting, we are getting an error that says, this person has insufficient permissions to add this team member to this organization. So good, we love that. The OpenFGA is working. Amazing. And SQLite and Postgres are still up to date. So no weirdness there, no dual write problem. The dual write problem really comes in if there's any sort of network latency or issues within this distributed system, right? So that's what we're going to simulate next. So we know that Alice should be the one being able to do this because she has these godlike permissions. And we are going to kick off a new workflow with her. And then we're going to actually kill Postgres right away just to see what this is going to look like. So I'm going to kick this one off here. I'm going to hop over to Docker desktop. And I'm just going to stop my Postgres container. So this is simulating OK, for whatever reason, Postgres went down. Whatever, someone put in the wrong, Jose put in the wrong connection string. Again, why we got to do that? We're going to see this retrying a few times. I'm just going to stop that so we can see those logs. One thing I didn't mention is that, so yeah, this is retrying a couple times because I have a built-in, or because I have a resiliency policy within my workflow. So one of the other things Dapr Workflows does really nicely is it gives you these options to create retry policies that are specific to each activity. So if I want this, maybe my Postgres is kind of latent and I want this call to my Postgres database to retry and maybe others don't, I have specified this retry policy saying, hey, I want to retry 10 times. I want to do after 1 second. I want a backup coefficient of 1, et cetera, et cetera, et cetera. And that is kind of what we're seeing. If I go down here, this kind of retry, hey, we're retrying Postgres. It didn't work, so I just stopped the workflow for now. So far, what we are at is we are at a state in which we have Doug sitting in this local SQLite database. Again, that's my local application database. But then and then if I show you okay, I better bring Postgres back up just to show you that. Start. Lovely. And then if I take a peek at kind of what's going on within Postgres, I'm going to see, hey, I have Alice, Bob, and Charlie, but like no Doug. So this is like kind of the epitome of this, dual array problem. I have two databases, they're supposed to be up to date, and this could lead to all sorts of issues with, giving someone permissions that don't exist for them yet, or that shouldn't exist, things like that. And it could also be a security risk. So let's now pick this one back up. So I'm just going to, okay, so Dapr's still running. I'm gonna rerun Dapr in there. And I'm just going to rerun my application. I'm not going to do anything, though. I'm not like touching anything. I'm not like running any fun commands in the back end. I'm just going to let it go. And we got an internal server error. No, team member side organization, true. OK, wait, let's just see what this looks like. All right, but we got Doug in the database. Yay, Doug's in the database. So essentially, what did we see there? We have Alice, Bob, Charlie, and Doug in our KubeCon SQLite thing running locally. And then we also have Alice, Bob, Charlie, and Doug. So essentially, even though I think this external server error was from one of the last calls that was coming in through the retry from last time. But anyway, we actually finished that workflow without doing anything on our side. It picked up from where it left off, and it completed by adding that to that Postgres database. Cool, so that was most of the kind of resiliency part. I just wanted to, yeah, I guess that was mostly it. I wanted to thank you for coming. And if you have any questions in terms of Dapr workflows or resiliency or OpenFGA or anything along the lines of that, please stay and ask questions. Thanks. I thought I had one more thing to say. I was like, what was the last thing I was going to say? Oh, and then please leave us feedback if you guys have 1 minute. That would be great. I don't know how to turn this off. I don't know why I got an external server there, but that's fine. Yes.
Hello, can you hear me? No. Great talk. Thank you very much. I was wondering, is it possible to code a different method? Like, let's say, not database connection, but something else is entirely down, and that's not going to work. So can we have, after this many retries, send this to that letter queue, or send it to my retry queue and do something else? Yeah,
100%. Great question. So essentially, one thing, yes, it's literally just code at the end of the day. So you can do whatever you want, so long as you're keeping those activities, like I said, entirely deterministic. Totally. What we're doing here, and I kind of maybe glazed over this a bit, but we're actually calling any sort of error handler, we're ensuring that every single thing has been rolled back. So you could on any exception that was thrown or in any case that was returned from any of those activities, branch off and do something that you wanted within that workflow. You just have to remember that, again, this is the workflow thing that is being checkpointed. So it's going to kind of pick up and continue running, and then the activities themselves are the things that need to be that deterministic piece of work within the main workflow definition. Okay. So yeah, within those confines, absolutely.
Yeah, I was thinking rate limiting, for example, in mind. I'm trying something and just returning 429s, and then I can be customize this enough to retry again in 30 minutes, or retry when retry doing something differently entirely.
Totally. And I think one of the things that is powerful about this is again, these retry policies can be very specific per activity. So if you're all right, I want, if this happens, if this is failing, let's make a, back off that is 10 minutes long. Let's give it some time to recover before we're just accidentally hitting it again and again. But yeah, good questions. And one other benefit is you can use any of the other regular Dapr APIs just within this, or you can use any of the SDKs for Kafka or anything like that. So just code. Yeah.
Thank you.
Yeah, good question. Yeah. No worries.
Hello, great talk. A couple questions. First thing I'm curious about is performance. What does performance overhead look like for this workflows?
Yeah, good question. We, since the Dapr workflow engine is running locally within the same pod, so it's a sidecar injected in your same pod, it's typically pretty good. It also very much depends on the database you use. So we've done a ton of like performance testing and benchmarking against like Postgres, and it performs very, very, very well. But like other databases, we've like absolutely had issues with for sure. So we have some kind of best practices in which databases we recommend using because it is fairly write heavy from like a database process perspective. So I would say those two are two big things, but it is very, very, very quick. Again, living within that same pod.
Is it best practice to leave the database with the sidecar, or is it like a centralized Dapr database if you have multiple pods and sidecars?
It's centralized. So like, for example, there's a single like Dapr workflow state store that would be used for like all of your workflows. And then the workflows themselves are namespace, like within Kubernetes. So they live within that kind of namespace construct, meaning that like each workflow would be calling out to that within that namespace. So one to many, sidecars one-to-one, obviously, and then one database to many sidecars for workflow.
Cool, that makes sense. My second question is I want to better understand the failure case. So in the demo where it failed,
yes,
we successfully wrote to the application database, I guess you could say.
Yes.
That succeeds. We failed to write to the authorization database.
Yeah, exactly.
After the configured retries, did it roll back what was written?
Good question. Yeah, it didn't hit the total number of retries. I like killed the workflow just because I wanted to I wanted to turn on the database to show it actually completing successfully. So, but if it would have hit, in this case, I have like 9 retries, so 10 attempts total. After 10 attempts, it would have thrown an execution error, and it would have rolled back based on what I have set in this error handler. But what actually happened was, it did I think 4 or 5 retries. I could check, and then I killed the workflow. I started Postgres again, and then I continued the workflow on, so it actually could succeed successfully. Just showing all right, what happens if that Postgres connection kind of came back online? You were actually able to talk to that DB, then that would all kind of work.
Okay, that makes sense to me. So my question in this then is, the number of retries fails and the rollback happens. What happens if the rollback fails? What if the application database is down then?
Yeah, good question. I would say this is kind of where, again, all these resiliency and retry, it will, depending on what your retry policy is set to be, that is going to continue for a certain amount of time. Also, let's say, you're running a Kubernetes, that pod goes down. Once it comes back up, it's going to try and complete again. It's going to just continue trying is the answer until it either fails or it doesn't work. Yeah.
If you get past the retries, will you be in a bad state? And then what would happen if you ran the workflow again?
If you get past the retries, then it'll throw this exception and you'll be in that compensating action loop, right? So if you get to this piece of code is written so that any sort of exception that is thrown, it'll just do that rollback if, blanket exception. So it's going to delete it from the database locally, and if it is present in OpenFGA, also delete it from OpenFGA. So specifically, we wrote a custom compensating action to account for our business processes, which is the recommended best practice there. Does that make sense?
Yeah, I guess I'm trying to understand, will that just keep trying forever, the rollback though?
So again, it goes back to what you set your resiliency policy as, right? You can set it to that, you can set it to be that, but it very much depends on this business process. So if you were I want it to retry forever because this is going to be huge. Oh, I want it to retry for 10 minutes, and then we don't consider data relevant after 10 minutes. Oh, you know what I mean? There's many use cases. So yeah.
That's helpful.
Okay.
Thank you.
Yeah, no worries.
Really good presentation.
Questions. Thank you.
Regarding development workflow,
Yeah.
is the expectation that people would be running Dapr locally for local dev, or is there a central dev Dapr? What's the model there?
Yeah, great question. So for example, I'm running Dapr locally. If you saw on my Docker desktop, it has a Docker dependency typically, or you can use another kind of container engine, but you can also run Dapr 100% just on VMs if you want to. What we typically see is people running Dapr locally and with Docker, or using a compose setup as well. It also depends what language you're using. There's a lot of tooling. It works really well with .NET Aspire. If you're a .NET developer, we have a lot of Spring integrations for Java, things like that.
Okay, and then how does this work with testing as well? When we're doing automated,
Yeah, good question. For testing, again, because you can spin up a lot of these dependencies running locally, so I don't know if I showed this pretty quickly, but the idea of components is like pretty key within Dapr. It is going to be that abstraction on top of your infrastructure. So like I'm testing in this case with like Redis as my append-only state store, but like I could just swap that component out and use like whatever I wanted as I kind of moved up my environments, right? So like we see a lot of people running locally using some sort of like Redis container and then switching out their database to being something more production ready or something different when they move to like production. So I guess the answer is there is a lot of tooling for testing. We also integrate with like test containers running locally. We also integrate with a couple .NET for testing frameworks, things like that.
Okay. And then as well, I had a question regarding the OpenFGA, that spec we were looking at earlier that was codifying the permissions that we had. Is there some way for me to convert that spec that you had into strings that my program can use so that I'm not like rewriting?
Can we take that and the next question outside because we're wrapping up? But yeah, find me.